Welcome to Sankalp Learning Classes. In this session, we'll be discussing 1 mark questions of the chapter continuity and differentiability. So, before starting questions, we'll discuss the important points that are in the chapter continuity. So, the first point is, what do you mean by continuity, right? So, we have defined the continuity of a function at a point, right? So, what do you mean by continuity of a function at a point? At a point means let that point be A. So how can you say that the function is continuous at the point A? What are the conditions? That is, the conditions are, I hope everybody knows all those things. That is, f of A should be defined. Then there is left limit, right limit, right? So if and the function is approaching from the left side, and if it is approaching from the right side, both the limit of the function should be equal at that point, right? And that value should be equal to the function value at that point, right? So that is the third condition. This right limit and left limit should be equal to f of a. Okay, so these are the important conditions for a function to be continuous at a point, right? And so how can you say that a function is in general continuous? This is continuity of a function at a point, right? So a function in general, a function is continuous if it is continuous at all points of its domain. Function has a domain and range, right? So domain means a set of all values in which the function is valid or function is defined, right? So if it is continuous at all points of the function's domain, then we can say that the function is continuous. Okay, so what is a graphical approach? If you are given a graph and to check whether the function is continuous or not, it is easy actually. The thing is that you have to observe whether there is any break in the graph. Okay, if there is any break in the graph, we can say that it is discontinuous, and if there is no break in the graph, we can say this it is a continuous function. All right. For example, so this is a graph of the function f of x equal to x square. You can see that there is no break in this graph, right? So here you can see that this is a graph. Is there any break? No break, right? So this function can be said that it is continuous. All right. So we are moving on to the next topic. And here they have given some important continuous functions. They are the constant function is continuous, identity function, then modulus function, exponential function, log function, polynomial function, rational functions, and trigonometric inverse trigonometric function. So these all functions are continuous in their respective domain. All right. Now we are moving on to the next topic. We know algebra of continuous functions. What is it? If you are given two continuous functions, then there is addition, okay, their subtraction, their multiplication, their division, provided that the denominator is not equal to 0, then their composition are all continuous. All right. Now, what do you mean by a derivative of a function? So, derivative is defined by limit s tends to 0, f of x plus h minus f of x by h. Okay, so what are its notation? It can be denoted as f dash of x or dy by dx. And if you are given some function like y equal to f of x, you can represent the derivative as y dash, or you can represent it as y1. Okay, if you are derivating a function for the first time, it is y1. Okay, so these are the notations of derivative, and we know every differentiable function is continuous. Okay, every differentiable function is continuous, but we can't say the reverse is true. That is, every continuous function is differentiable. And if we approach the differentiability through a graphical approach, what we can say, if there is a sharp turn or sharp corner in the graph of a function, we can say that the function is not differentiable at that particular point. For example, if you consider the graph of modulus function, you can see that there is a sharp turn at the point x equal to 0, right? X equal to 0, you can see a sharp turn or a sharp corner. So we can say that a graphical approach of differentiability says that at that point, the function is not differentiable. So x equal to 0 is a point of modulus function in which the function is not differentiable. All right. So, what about the continuity of modulus function? You can see that from the graphical approach, you can see that there is no break in the graph, right? Is there any break in the graph? There is no break in the graph, which means that which means modulus function is continuous. Okay, modulus function is continuous, but the thing is that it has a sharp turn at x equal to 0, so it is not differentiable. So we can say that every differentiable function is continuous, but it is not necessary that every continuous function is differentiable. All right, so these are all important points. And I hope everybody knows the standard derivatives, right? X raised to n is nx raised to n minus 1. Constant, the derivative is 0. Derivative of 1 by x is minus 1 by x square. A raised to x is a raised to x log a. And what about e raised to x? E raised to x, the derivative is e raised to x itself. And what is log x to the base a? It is 1 by x log a. Then log of x. What is the derivative of log x? It is 1 by x. Root x is 1 by 2 root x. Sin x is cos x. Cos x is minus sin x. Tan x sec square x. Cosec x minus cosec x cot x. Sec x is sec x tan x, and cot x is minus cosec square x. All right. Now, in this chapter, we'll study about some more derivatives. That is, we have studied about inverse trigonometric functions. So, we'll study the derivatives of those functions also in this chapter. So, these are given here. Okay. So, sine inverse x, derivative of sine inverse x is 1 by root of 1 minus x square. And what about the derivative of cos inverse x? It is 1 by root of 1 minus x square, but it has a minus. Okay. So, that's how you connect and study these um, uh, derivatives. All right. So tan inverse x is 1 by 1 plus x square. And what about cot inverse derivative of cot inverse x? It is minus 1 by 1 plus x square. And derivative of sec inverse x is 1 by x root of x square minus 1. What is the derivative of cosec inverse x? It is minus 1 by x root of x square minus 1. Okay. And now, these are some algebra of derivative. That is, if you are given two differentiable function, okay. So, and if you are asked to find out the derivative of some of these two differentiable function, then what you should do is that you find them derivatives, find the derivatives of the function separately, and then you add or subtract it. All right. So, this is the first one. D by dx of f of x plus or minus g of x equal to d by dx of f of x plus or minus d by dx of g of x. And what is the product rule? Product rule means d by dx of f of x into g of x means how will you find out the derivative? It is the derivative of the first function into second function, or you can follow any order because addition is always commutative, right? So you take the first function f of x into derivative of the second function, it is g of x, right? Then plus you write the second function, then into derivative of first function. All right. So this is the product rule. And what about the quotient rule? If you are given a function like f of x by g of x, what you have to do is that first you write the denominator. Okay, that is g of x. G of x into, you have to find out the derivative of numerator, d by dx of f of x. Then you subtract minus, you write the numerator, then you find the derivative of denominator. And now what you have to do is that you have to divide it with the denominator square. Okay, so this is a quotient rule. And now we are moving on to the next rule. That is the chain rule. So what do you mean by this chain rule? If you are given a function that is your a composite function, if you are given a composite function, what you have to do is that you have to apply the chain rule. That is, if you are given a function like uh, cos of x square. Okay, instead of cos x, it is given as cos of x square, which means there are two functions. What are the functions? Cos of x and x square, right? So this is a composite function. Okay, this is a composite function. So how will you find out the derivative of such functions? You have to apply chain rule. And what is this chain rule? First, you have to identify the base function here, which is a base function, cos of x square, which is a base function. It is nothing but cos x. But in the place of x, you can see that there is another function, and which is that function x square. So you find the derivative of the base function as normal. That is, what is the derivative of cos x? It is minus sin x. So what is the derivative of cos x square? It will be minus sin x square. It will be minus sin x square because in the place of x it is x square. So you have to write it in that that itself. That is x square itself. But you don't have to. You should not have to stop there. That is, you have to find out the derivative of the function that has occurred in the place of x also. That is, what is the derivative of x square? It is X square means it is in the form of x raised n, right? So the derivative is nx raised n minus 1. Here n is equal to 2, right? So it is 2x raised to 2 minus 1, right? So that is equal to 2x. 2 minus 1 is 1. So it is 2x. So what is the derivative of x square? It is nothing but 2x. So you have to multiply the derivative of the function that has occurred in the place of x also. Okay, this is how you find out the derivative of composite function using chain rule. Okay, now what do you mean by this implicit differentiation? You are familiar with functions like y equal to some functions in x, right? So these type of functions are known as explicit function. That is, we can represent those functions like y equal to something. That is something which is in the variable x. Okay, so implicit functions are those functions which we cannot represent like that. For example, if you consider x minus y equal to pi. Okay, x minus y equal to pi. And if I take this y to the other side, this will become x minus pi equal to y. That is, now you can say that y equal to x minus pi, which means y can be represented as some function of x, right? So these type of functions, we can easily represent like that, right? So these type of functions are known as explicit function. We can write it as y equal to some x. Okay, but what do you mean by this explicit function? Explicit functions means we cannot represent it as some y equal to f of x. It will be a mix of x and y functions. Okay, so such functions are known as explicit functions. All right. So, for example, if I write y plus sin y equal to cos x. Here, can you write y equal to some function of x? No, right? It is y plus sin y. This is also a function in y equal to cos x. So these type of functions, which are a combination of this x and y functions, is known as implicit function. So implicit differentiation is given there. How will you do that? First, we have to differentiate that function with respect to x and then solve for dy by dx. We'll understand this while doing problems. All right. So what do you mean by logarithmic differentiation? If a complicated functions like f of x equal to u of x raised to v of x is given, then we apply logarithmic differentiation. That is, we apply the rule log of a raised m is equal to m log a. We apply this rule in order to solve such problems. Okay. Now, parametric differentiation means if these here relation between two variable x and y, which are expressed in the form of x equal to f of t, y equal to g of t. So x can be represented as some function t, and similarly y can be represented as some function in t, which means x and y have some relation, right? The connecting factor or the parameter that connects x and y is t. So that is known as parameter t, and these type of functions are we find the derivative of these type of functions using the parametric differentiation. That is, we'll find the derivative of y with respect to t, and then we'll find the derivative of x with respect to t, then we'll divide those, then we'll get the dy by dx. All right, so this is parametric differentiation, and now we have one more, that is a second order derivative. That is, if a function is first derivative, we can find the derivative of the function, and we can again find the derivative, that is known as the second derivative of the function with respect to x. Okay, so we are derivating a first derivative, we are finding the derivative of the first derivative, so it will become second derivative. Okay, so the notations are d square y by dx square, f double dash of x, and y2 or y double dash. See, these are all the notations of second derivative. Okay, Okay, so this is our first question. That is, if y equal to log of log x, then find dy by dx. Okay, so in this chapter we'll have a total of 17 mark questions. Okay, so there will be three questions from the 1 mark section. That is, one will be the fill in the blanks and two questions will be MCQ. Okay, so the first question here given is, it is fill in the blanks. That is, y is log of log x, and you have to find out the derivative of that function, derivative of y. Okay, so how will you do that? It is log of log x. You know the derivative of log x. Log x is 1 by x, right? So here it is a composite function, right? Log of log x means in the place of x there is another function. That is, in the place of x of the log function, you can see that it is another function. Which is that function? It is log x itself. Okay, so here y equal to log of log x. It is y equal to log of log x. And what is the derivative of this function? It is dy by dx is equal to. Okay, derivative is, we know log x. The derivative of log x. Derivative of log x is 1 by x. It is 1 by x, right? Here it is log of log x. D by dx of log x. So you have to identify the base function, right? So which is a base function? This log x, right? In the place of x, it is another function. So what is the derivative of log x? It is 1 by x, but in the place of x, it is log x. So it will become 1 by log x. And can we stop here? No, we have assumed x as log x. So we have to multiply the derivative of that function also. So what is the derivative of log x? Log x is, so here, this log x is assumed as x. So what is the derivative of that one? It is 1 by x. So you have to multiply 1 by x also. So what will be the answer? 1 by x log x. It is 1 by x log x. All right. Now we are moving on to the next question. So this is the second one. Y equal to sec of tan root x. Then you have to find out dy by dx. How will you do that? Y equal to sec of tan root x means, what is dy by dx? It is d by dx of sec of tan root x. Sec of tan root x here, which is the base function here. Which is the base function. It is nothing but sec x. But in the place of x, you can see that it is another function. It is tan root x. Okay, if you observe tan root x, then also you can see two functions there. Because in the place of x, there is another function, that is a root x. Which means this is a combination of three functions. Which are those functions? Sec x, tan x, and root x. So these are the compositions of three functions. All right. So base function we have identified. It is sec x. But in the place of x, there is another function, or there is a composition of two functions, right? So you find the derivative of sec x. What is sec x? Sec x tan x, right? Derivative of sec x is sec x tan x. But in the place of x, it is tan root x. So how will you write it? Sec of tan root x, right? It is sec x tan x, but in the place of x, it is tan root x. So what is the derivative? Sec of tan root x into tan of tan root x into tan of tan root x. Okay, but can we stop here? No, we have to multiply the derivative of the function that we have assumed as x. So here we have assumed this one as x, tan of root x, right? So what is the derivative of, here the base function is tan, right? So what is the derivative of tan? It is sec square x, right? So sec square, and we have assumed in the place of x as root x. So it will become sec square root x. Sec square root x, right? And can we stop here? No, because we have assumed, we have taken root x in the place of x, right? So we have to multiply the derivative of root x also. So what is the derivative of root x? It is nothing but 1 by 2 root x. It is nothing but 1 by 2 root x. So what is the derivative? Sec of tan root x into tan of tan root x into sec square root x by 2 root x. So what is the value? It is nothing but c. It is nothing but c. Now, this is a third one. Y equal to sine of cos x square. And what is dy by dx? You have to find out dy by dx. Here also it is a composite function. It is a composition of three functions, which are the sine x, cos x, and x square. right? So which is a base function here? First, you have to identify the base function. It is sin x, because you can see that in the place of x value, there is another function, it is cos x square. So the base function is sin x. So what is the derivative of sin x? It is nothing but cos x. But in the place of x, it is cos x square. So instead of cos x, it will become cos of cos x square. Right? So can we stop here? No, because we have to find out the derivative of cos x square, because we have assumed that function as x. Okay, so what is the derivative of cos x square? Here also the base function is cos. So the base function derivative of cos x is minus sin x, but in the place of x it is x square. So you have to write minus sin x square. Right? You have to write minus sin x square. And here you can say that in the place of x, it is, we have assumed it as x square, right? So we have assumed x square, the function x square as x, right? So we have to multiply the derivative of x square also. What is the derivative of x square? It is nothing but 2x, right? So this into 2x. Okay. So what is the derivative here? It is minus 2x cos of cos x square into sin x square. So option D is right. All right. Moving on to our next question. So y equal to cos inverse of sin x, and you have to find out dy by dx. Okay. You have to find out dy by dx. So which is a function d by dx of cos inverse of sin x. D by dx of cos inverse of sin x. So we know the derivative of cos inverse of x. What is the derivative here? Also, you can see that it is a composition of functions. Which are those functions? One is inverse function and the other is a trigonometric function. So cos inverse and sin x, right? So in the place of x, sin x has occurred, right? A function sin x has come in the place of x, right? So we are assuming this sin x, the function sin x as x, and then we are finding the derivative of the function. Okay, so what is the derivative of cos inverse x? It is nothing but minus 1 by root of 1 minus x square, right? Minus 1 by root of 1 minus x square. But we have assumed the function sin x as x, right? That's how we are finding the derivative. So in the place of x, you have to write sin x, right? So this is sin x the whole square or sin square x. Okay. And you can stop there because we have assumed sin x as x. You have to multiply the derivative of sin x also. So what is the derivative of sin x? It is nothing but cos x. So you have to multiply it with cos x. So what is the value here? Minus cos x by root of 1 minus sin square x, right? Root of 1 minus sin square x. And what is this root of 1 minus sin square x or root of 1 minus sin square x? We have an identity. Sin square x plus cos square x is equal to 1. From this, how will you find cos square x? Cos square x is equal to 1 minus sin square x. So what is cos x? Cos x is equal to root of 1 minus sin square x, right? So what is the denominator here? Denominator here is nothing but cos x itself. So this is equal to minus cos x divided by cos x, right? Denominator is cos x. So it is minus cos x divided by cos x. So what is the value here? Cos x and cos x gets cancelled, right? So what is remaining? It's minus 1. So the answer is minus 1, that is D. D is the answer. All right. Now, the next question is you have to find out the derivative of 2x plus 3y equal to sin x. 2x plus 3y equal to sin x. So, can you identify which type of differentiation that we have to use here? Yes, it is nothing but implicit differentiation. It is implicit differentiation. Why it is an implicit function? Because you can clearly observe that it is um, it is in the form of 2x. Actually, you can apply this also. Um, Explicit differentiation also, but we can easily find it out using the implicit differentiation. So how will you do that? 2x plus 3y equal to sin x. How will you do this? So first we can write this one as 2x plus 3y equal to sin x. Okay. So here You can do this one like this also. 3y equal to sine x minus 2x. Okay, what is y? Y equal to sine x minus 2x by 3. Sin x minus 2x by 3. So this is y, right? So what is dy by dx? Now you find out the derivative of y with respect to x. So what is dy by dx? This 1 by 3 is a constant, so we are taking this outside, okay? And what is the derivative of sin x? It is cos x, right? Minus, what is the derivative of minus 2x? We know it is, we can split this derivative, right? If you are given a function in the form of f of x minus g of x, we can split the derivative. That is, first you find out the derivative of sin x, then you find out the derivative of 2x, then you subtract it, right? That is a method, right? So here also I'm doing it that way. That is, first we found out the derivative of sin x, it is nothing but cos x. And what is the derivative of minus 2x? What is the derivative of minus 2x? D by dx of, you find out the derivative of 2x. Okay, what is it? 2 is a constant and derivative of x is with respect to x is 1, right? D by dx of x is equal to 1, which means this one is a constant, so you can take this outside. So d by dx of x. So what is the value here? 2 into 1, that is equal to 2, right? So the derivative is 2. So what is the value here? It is cos x minus 2 by 3. Cos x minus 2 by 3. So the answer is option B. Cos x minus 2 by 3. Here also, this one is also actually explicit differential, explicit function itself, because you can easily write y equal to some function of x, right? So this can be easily found out using the method that we have followed till now, right? No, this one is our next question. So the function f given by f of x equal to modulus of x minus 1 is, you are given four options, you have to choose the right one. Okay, so they are saying that it is discontinuous and differentiable at x equal to 1. What can you say about that? It is a modulus function, right? We know modulus function is continuous. We know modulus functions are, these are some standard functions that are continuous, right? So this is our modulus function, right? This is mod x. But here they have given us modulus of x minus 1. Modulus of x minus 1 means, so the graph will be like this, right? The graph will be at the point 1, you can see a sharp turn. So this will be the graph of modulus of x minus 1. Okay, from this graph, can you say it is continuous or differentiable? You can say that it is continuous, right? Is there any break in the graph of this function? There is no break in the graph. So we can say that this is a continuous function. This is a continuous function. And what about differentiability? What about differentiability? You can say that at the point x equal to 1, there is a sharp turn or there is a sharp corner. So what can you say from the graph about the differentiability of the function? It is not differentiable at the point x equal to 1. It is not differentiable at the point x equal to 1. So which is the option, which is the right option here? Continuous, but it is not differentiable at x equal to 1. It is continuous, but it is not differentiable. All right, so we are moving on to the next question. Left hand derivative of f of x equal to mod x at x equal to 0. Here again you have given the modulus function, but you have to find out the left hand derivative, right? You have to find out the left hand derivative. So how will you do that? How will you find out the left hand derivative? First of all, we can redefine the function. This is f of x equal to mod x, right? So what do you mean by modulus function? The values of a modulus function is, if x is greater than or equal to 0, it will be positive, right? X. And if x is less than 0, what happens? It is minus x. If x is less than 0, you have to take minus x, then only it will become a positive number, right? So this is how you define a modulus function. If it is less than 0, it is minus x, and it is greater than or equal to 0, it is x. Okay. And what you have to find out, you have to find out the left hand derivative, which means this is a notation, right? LF dash of x. LF dash of x. And what is the formula? Limit h tends to 0 minus, right? It is left hand derivative. So it is 0 minus f of x plus h minus f of h by h. Sorry, f of x by h. f of x plus h minus f of x by h. So this is a formula, right? And here, which is the x, here we have to check it at 0, right? So x is equal to 0. So this will become limit h tends to 0 minus f of 0 plus h minus f of 0 by h. Okay. Now what you have to do, you have to put this value, this 0 plus h in the place of x, right? So f of 0 plus h means f of h, and it is approaching from the left side, right? It is approaching from the left side, which means less than 0, right? We are checking at the point x equal to 0, which means it is approaching from the left side of x, which means it is less than 0. And at less than 0, the function takes which value? It is minus x, right? Right? So the function takes minus x when x is less than 0. Here we are finding out left-hand derivative, which means it is approaching from left. So we know which function to take, which function we should consider it is minus x. But in the place of x, you have to put 0 plus h, that is h itself, right? So this will become limit h tends to 0, f of h minus f of 0 by h, right? So this is equal to limit h tends to 0, f of h is minus h because it is approaching, it is left hand derivative, right? So minus h. And what is f of 0? F of 0, you put uh, 0 in the place of x. What is f of x? F of x is equal to x when x equal to 0, which means f of 0 is equal to 0, right? So what is the value of f of 0? It is nothing but 0 divided by h. So this will become limit h tends to 0 minus h by h, right? Minus h by h, and h gets cancelled. So what is the value? It is nothing but minus 1. It is nothing but limit h tends to 0 minus h by h is equal to minus 1. Okay. So which is the option? B. B is the right option. B is equal to minus 1 is the answer. Now, which one of the following is not true? You have to find out um, which of the following is not true. Okay, the first statement is every polynomial function is continuous. Is that right? Every polynomial function is continuous, right? We have studied that every polynomial function, then rational function, when the denominator is not equal to 0 is continuous, right? So the first statement, polynomial function is continuous, every rational function is continuous, and every differentiable function is continuous. That also we have studied. And the last one is every continuous function is differentiable. No, it is not true. Every differentiable function, we can say that it is continuous, but continuous function doesn't create the necessary condition for a function to be differentiable. So every continuous function is not differentiable. It is not differentiable. So which of the following is not true? Option D is not true. Example we have already explained, it is nothing but mod x. Mod x is continuous, but it is not differentiable at x equal to 1. Okay. So we are moving on to the next question. A function f is said to be differentiable for x belongs to R. A function is differentiable if it is continuous, right? If it is continuous. So which statement is correct here? If it is continuous for x belongs to R. A function f is said to be differentiable for x belongs to R if it is continuous for x belongs to R. Okay. Now, the next question is the function f of x equal to mod x plus 1 plus modulus of x minus 1 is. So they have given a function f of x as a addition of two functions. Let the first function be g of x and the second function be h of x. Now what can you say about g of x and h of x? What is the g of x here? G of x is equal to modulus of x plus 1 and h of x എന്ന് പറയുന്ന h of x is equal to modulus of x minus 1, modulus of x minus 1, right? So these are two functions, both are modulus function. We know that modulus functions are continuous, right? So this x plus 1, the graph of the x plus 1 will look like this, okay? So if this is minus 1, this is a graph of x plus 1, and graph of x minus 1 means if this is the point 1, the graph will be like this. So these are two functions, g of x and h of x, and we know both of these functions are continuous. Is there any break in the graph of these functions? No. Here also, if you observe that, is there any break? No. So which means both of these functions are continuous separately. So from the algebra of continuous function, we have studied that the sum f plus g, if you are given two functions that are continuous, then their sum or subtraction, etc. are all continuous, right? Composition, division, and multiplication, the product, everything is continuous, which means here you are given two functions, two continuous functions, g of x and h of x, and we can represent this f of x as g of x plus h of x, which means f of x is also a continuous function. F of x is also a continuous function. And here you can see that f of x, the first function is modulus of x plus 1, right? So this is the graph. Here you can see that it is continuous at x equal to minus 1, right? It is continuous at x equal to minus 1. And what about h of x? If you observe h of x, you can see that h of x, the function h of x is continuous at x equal to 1. Is there any break at x equal to 1? No. So it is continuous at x equal to 1. So from that, you can say that the function f of x, it is a sum of these two functions, right? So in general, this function f of x can be, we can say that it is continuous at x equal to minus 1 as well as x equal to 1. At both the points, the function is continuous. All right, now we are moving on to the next question. So y equal to sine inverse x plus sine inverse of root of 1 minus x square. Then you have to find out dy by dx. Okay, you have to find out dy by dx. So how will you do that? So first we can write y equal to sine inverse x plus sine inverse of root of 1 minus x square. Sine inverse of root of 1 minus x square. So first you find out the derivative of sine inverse x. Then you find out the derivative of sine inverse of root of 1 minus x square. Then if you add, then you will get the dy by dx, right? So first of all, what is the derivative of sine inverse x? It is nothing but 1 by root of 1 minus x square, right? Sine inverse x derivative is 1 by root of 1 minus x square, plus what is the derivative of sine inverse of root of 1 minus x square? Sine inverse of root of 1 minus x square. In the place of x, you can see that there is another function, right? In the place of x, it is another function. Sine inverse of 1 by root of x, root of 1 minus x square. In the place of x, it is a function root of 1 minus x square. So we are assuming that function as x. And then we are finding the derivative. Okay, applying the chain rule. So what will happen here? It is 1 by root of 1 minus root of 1 minus x square, right? Root of 1 minus x square, the whole square. Because we have assumed the function root of 1 minus x square as x. So you have to take the square of that function, right? So this will become root of 1 minus x square, the whole square. Okay, so can we stop here? No, because we have assumed root of 1 minus x square as x. So you have to find out the derivative of that also. Root of 1 minus x square. And which is the base function there? Root of 1 minus x square. We know the base function is root x, right? But in the place of x, it is 1 minus x square. So you take this 1 minus x square, or you assume that 1 minus x square as x, and then you find the derivative. So what is the derivative of root x? It is 1 by 2 root x. It is 1 by 2 root x, right? 1 by 2 root. And here in the place of x, it is 1 minus x square. It is 1 minus x square. Okay. And again, we can't stop here because we have assumed 1 minus x square as x. So you have to multiply the derivative of 1 minus x square also. So what is the derivative of 1 minus x square? D by dx of, what is the derivative of 1 minus x square? Okay, which means d by dx of 1 minus d by dx of x square, right? So what is the derivative of 1? It is 0. And x square. X square means it is of the form x raised to n, where n is equal to, 3. Where n is equal to 3, right? Sorry, n is equal to 2. So, what is the derivative? It is nx raised n minus 1, right? Which means 2x raised to 2 minus 1, that is equal to 2x. So, the derivative is 2x. So, d by dx of 1 minus x square is nothing but minus 2x. Here there is a minus, right? So, minus 2x. Okay, now what you have to do is that we have to simplify all these. So, this 2 and this 2 gets cancelled, right? Okay, so this will be 1 by root of 1 minus x square, then plus 1 by root of 1 minus x square, the whole square means root will go, right? Root and this 2 gets cancelled. That is, root means 1 by 2, and this 2 gets cancelled. So this will become 1 minus x square, right? 1 minus x square into x by root of 1 minus x square. X by root of 1 minus, it's minus x. This is 1 by root of 1 minus x square plus 1 by root of 1 minus 1 plus x square. Okay. Into minus x by root of 1 minus x square. Okay, it's actually simplification. So this will become 1 by root of 1 minus x square uh, minus what was our previous step. So this will become x square, right? The denominator will become root of x square. 1 minus 1 is 0. It is root of x square. Root of x square means it is x, right? So the next step is plus 1 by x because it is root of x square. Okay. Into minus x by root of 1 minus x square. Root of 1 minus x square. Okay. So this is equal to 1 by root of 1 minus x square. This x and this x gets cancelled. Minus 1 by root of 1 minus x square. So what is the value here? It is nothing but 0. It is nothing but 0. So which is the option? C option is right. 0. Alright. So we are moving on to the next one. So this is our next question. If y equal to a raised x plus x raised a plus a raised a, then you have to find out dy by dx. Okay. So first we can write the function y equal to a power x plus x power a plus a power a. Okay. So this is our function. We know the derivative of, we have to find out the derivative of this function. So we can apply or we can find the derivative separately and then add it, right? So which means d by dx of a raised x plus d by dx of, the second one is x raised a, okay, plus d by dx of a raised a. Okay, so these are the functions. And what is the derivative of a raised x? What is the derivative of a raised x? If y equal to a raised x, what is dy by dx? What is dy by dx? It is a raised x log a, right? It is a raised x log a. So here the first one will be a raised x log a plus, what is the second function? This x raised a. If a function is of the form x power n, we know the derivative nx raised n minus 1, right? So here in the place of n, it is equal to a. So what will be the derivative? What will be the derivative? A into x raised to a minus 1, right? A into x raised to a minus 1. So the second derivative is ax raised to a minus 1 plus d by dx of a raised to a. A raised to a is a constant, right? So what is the derivative of a constant number? What is the derivative of constant number? It is nothing but 0. So a raised to x log a plus a raised to x a minus 1. This is the derivative. So which option is right here? This one. C option is right. A raised to x log a plus ax raised to a minus 1. Alright. Now we are moving on to the next question. So the derivative of e raised to log x to the base e with respect to x's. Okay, so to the base e means it is natural logarithmic function, right? If it is base 10, then it is a common logarithmic function. Okay, so here it is given e raised to log x to the base e. We know the property of the exponential and logarithmic function, that is e raised to log x is equal to nothing but x itself. What is e raised to log x? It is nothing but x itself. So what is here? The answer here, they are asking about the derivative of e raised to log x. Okay, they're not asking the value of e raised to log x. They are asking the derivative of e raised to log x. So if you know the property e raised to log x is equal to x, then if you are asked to find out the derivative of e raised to log x, that is, you are asked to find out the derivative of e raised to log x, and you know this property, then how will you do that? If you are, then this will be equal to d by dx of x, right? Because e raised to log x is equal to x, we can replace it with x. So it will become d by dx of x. And what is the derivative of x with respect to x? It is nothing but 1 itself. It is nothing but 1. Okay, so option C is right. Now, moving on to our next question. So the derivative of e raised to minus x with respect to x. We know the derivative of e raised to x. What is the derivative of e raised to x? It is nothing but e raised to x itself. But here it is minus x. In the place of x, you can see that it is minus x. So you have to assume this minus x as x, and then you find out the derivative. That is, here you have to apply the chain rule, right? So dy by dx, and what is this y? It is nothing but e raised to minus x. But in the place of x, you can see that it is minus x. So you assume that value as x itself, and then you find the derivative. So the base function is e raised to x, which means the derivative will become e raised to minus x, because in the place of x it is minus x. And then you don't have to stop here. You should not stop here. You have to multiply the derivative of the function that you have assumed as x. So here I have assumed minus x as x, right? So what is the derivative of minus x with respect to x? Derivative of minus x with respect to x is nothing but minus 1, right? Isn't it? Because this can be written as minus 1 into d by dx of x, and we know the derivative of x is 1. So which is what is remaining? Minus 1. So d by dx of minus x is nothing but minus 1. So you have to multiply a minus 1 also. So this will become minus e raised to minus x. This will become minus e raised to minus x. So which is the answer here? A option. Okay. A is minus e raised to minus x. Now, next one, y equal to root of e raised to root x. Then you have to find out dy by dx. Okay. So, y equal to root of e raised to root x. Here also you can see that it is composite function, and which is a base function. That is the basic thing that you have to do. You have to identify the base function. Which is the base function here? It is nothing but root x. Okay, it is nothing but root x. But in the place of x, you can see that it is again a composition of function. Which are those functions in the composition? It is nothing but e raised x and root x. E raised x and root x. Here in the place of x, it is root x. So this is a combination of two functions e raised to root x. Okay, so you assume this e raised to root x as x, and then you find out the derivative. Okay, so what will be the derivative? Dy by dx is equal to, we know the derivative of root x is nothing but 1 by 2 root x. Okay, so similarly, d by dx of root of e raised to root x is equal to, what will be that? 1 by 2 root of, here it is x, but here we are assuming this e raised to root x as x. So inside the root value, it will be e raised to root x. But can we stop here? No. We have to multiply the derivative of the function that we have assumed as x. So what is the derivative of e raised to root x? E raised to root x, we know the base function is e raised x. Okay, so in the place of x, you can see a function root x. So you find the derivative as usual. E raised x is, we know it is e raised x itself. So this will become e raised to root x. And then you multiply the derivative of this root x also. What is the derivative? It is nothing but 1 by 2 root x. 1 by 2 root x. So what is the value here? In total value, 2 into 2 will become 4. So 1 by 4 root of e raised to root x. And there is e above, right? E raised to root x, e raised to root x into 1 by root x. So this can be written as, here I'm writing the answer. It is e raised to root x. In the numerator, it is e raised to root x, and in the denominator, it is 4 into root of e raised to root x into root x. Okay, so this is our answer. So which option is right here? E raised to root x, 4 root x, root of e raised to root x. So option D is right. All right. Okay. So the derivative of e raised to sine inverse x with respect to x. You have to find out the derivative of sine inverse x with respect to x. D by dx of e raised to sine inverse x. E raised to sine inverse x. Okay. So here also you have to observe the base function. Which is the base function here? It is e raised to x. It is e raised to x. But in the place of x, it is sine inverse x. So you have to assume the sine inverse as x. Sine inverse x as x. Okay, so then you find out the derivative. So we know it is e raised to sine inverse x, or the derivative of e raised to x is e raised to x itself. So this will become e raised to sine inverse x, because in the place of x it is sine inverse x, and you have to multiply the derivative of sine inverse x. And what is the derivative of sine inverse x? It is nothing but 1 by root of 1 minus x square. 1 by root of 1 minus x square. So which is a value here? E raised to sine inverse x divided by root of 1 minus x square. So which is the option? A option is right. E raised to sine inverse x by root of 1 minus x square. Okay. Now, the next function is y equal to log 7 of log x. Then you have to find out dy by dx. Here you have to apply the property log b to the base a is equal to, we can write this one as log b by log a. Okay, log b by log a. Okay. So this one you have to apply here, which means this uh, log of log x to the base 7. Okay, this is to the base 7. So this can be written as, here this one is b and this one is a. Okay, so how can you write this one? Log of log x, right? Log b by log a. Here b is log x, right? And 7 is a. So log of log x by log 7. Log of log x by log 7. Okay. Now you find out the derivative of the function. So this is our y. So this is our y. Okay. And now you have to find out the derivative of this function dy by dx. And this log 7 means it is a constant number, right? So we can take this outside, that is 1 by log 7. And what is this? So here you write y itself. Y equal to 1 by log 7 into log of log x. Okay, log of log x. And what is dy by dx? Dy by dx means 1 by log 7 I have taken outside, and then log of log x. We have already found out the answer, right? It is a composition of two functions, log x and log x. In the place of x, it is log x. So you assume log x as x, and then you find out the derivative, right? So log x, the derivative is 1 by x. But here in the place of x, it is log x. So this will become 1 by log x. And you have to multiply the derivative of the function that we have assumed as x. Here we have assumed log x as x. So what is the derivative? It is 1 by x. So you have to multiply that also. So total the answer will be 1 by x log 7. Right? So which is the option here? 1 by x log 7 log x. So answer A. Option A is the right answer. Alright. We'll do this problem also. Y equal to x raised to 20. Then you have to find out d square y by dx square. Here they have asked to find out the second order derivative, right? So how will you do that? First, you have to find out the first order derivative, then again differentiate that one, then you will get the second order derivative. So the function is y equal to x raised to 20, which means it is of the form x raised to n. So dy by dx is equal to n into x raised n minus 1. N into x raised to n minus 1. Here n is equal to, here n is equal to 20. So how will you find out the derivative? Dy by dx or y dash. Okay, y dash. Okay, is equal to 20 into x raised to 20 minus 1. Right? That is 20 into x raised to 19. 20 into x raised to 19. Now, we have to find out the second derivative, that is y double dash, right? Which means d square y by dx square. So we have to differentiate this one again. Here also it is of the form x raised to n, right? 20 is a constant, so put it aside, that is 20 separately. Then x raised to, you differentiate x raised to 19. What is the derivative of x raised to 19? It is 19 into x raised to 19 minus 1, right? 19 into x raised to 19 minus 1. So this is equal to 20 into 19 into x raised to 18. 19 minus 1 is 18, right? So the answer is 20 into 19 is equal to 380, right? 380 x raised to 80. 380 x raised to 80. So which option is right? Option C is right. All right. So the next question is, derivative of f is given by f of x equal to sine inverse x, and it exists if x belongs to. So when can we say that the derivative of the function f of x equal to sine inverse x exists? We know the derivative of sine inverse x. What is the derivative of sine inverse x? dy by dx means d by dx of sine inverse x, right? D by dx of sine inverse x means it is nothing but 1 by root of 1 minus x square. It is nothing but 1 by root of 1 minus x square. Right. And we know that for a function to be, for a rational function to be defined, this denominator should never be equal to 0. Right? The denominator should never be equal to 0, which means this root of 1 minus x square should not be equal to 0. Okay, so we know the domain of sine inverse x. Okay. So here they have asked about uh, the domain of derivative of this function. Okay, so since this is a derivative of the function, which all values that x can take. Here, if I put -1 or 1, if x equal to -1 or x equal to 1, what will happen? It will become root of 1 minus 1. Root of 1 minus 1 will become 0, right? Which means the denominator, will be equal to 0. If denominator is 0, then we can say that the function is not defined, right? So which means x equal to -1 or x equal to 1 is not possible in that case. Because if you put x equal to -1 and x equal to 1, denominator be equal to 0, so the function will not be defined. So which all values can take from this is the basic domain of sine inverse x, which all values can take the derivative of sine inverse x. It can take all the values in between -1 and 1, but it cannot take the value -1 and 1. So how will you represent that in the form of an interval? In the form of an interval, then you represent it as -1 1 open interval, -1 1, because -1 and 1 cannot be included in the domain of the derivative of sine inverse x, because the denominator will be equal to 0, so the function will not be defined, right? So which is the option here? It is nothing but A. Option A, -1 1 is the answer. All right. Suppose f and g be two real functions continuous at a real number c. Then we know if f and g are two continuous functions, then f plus g, f minus g, f into g, f by g are all continuous, right? Here they have given that it is discontinuous. F plus g is discontinuous, so it is wrong. Then f minus g is discontinuous at x equal to c. Here they have given that these functions are continuous at c, right? So definitely there f minus g is also continuous at x equal to c. So this is also wrong. Here also they have given that it is discontinuous. F into g is discontinuous at x equal to c. So this is also wrong. So f by g is continuous at x equal to c, provided g of c should not be equal to 0. Okay, g of c should not be equal to 0. And the next one is y equal to cos of log x plus e raised x. You have to find out dy by dx. Okay, you have to find out dy by dx. So that is equal to d by dx of cos of log x plus e raised x. Log x plus e raised x. So here also it is a composition of three functions. It is cos x, log x and e raised x. In the place of x, you can see that there is a combination of two functions. It is log x and e raised x, right? So how will you do this? Find the derivative. Base function is cos x. So the derivative is equal to minus sign, right? Minus sign of, in the place of x, it is log x plus e raised x. Now we have assumed log x plus e raised x as the x value. So you have to multiply the derivative of that also, right? So this one into, what is the derivative of log x? It is nothing but 1 by x plus 1 by x plus, what is the derivative of e raised x? It is equal to e raised x. Okay. So which is the answer here? Minus sign of log x plus e raised x into 1 by x plus e raised x. Option D is the right answer. Moving on to our next question. So this is our next question. It is y equal to e power x plus e power x square plus e power x cube plus e power x raised to 4 plus e power x raised to 5. You have to find out dy by dx at x equal to 1. At x equal to 1. Okay, so what is this dy by dx? What is dy by dx? We know derivative of e raised x is e raised x plus e raised x square means e raised x square itself, but you have to multiply the derivative of x square because we are assuming x square as x, right? So derivative of x square is 2x plus e raised x cube means e raised x cube itself, but you have to multiply the derivative of x cube. What is the derivative of x cube? It is nx of the form x raised 10. So the derivative is nx raised n minus 1. Here n is equal to 3. So this will become 3x raised to 3 minus 1. That is equal to 2, right? Plus e raised to x raised to 4 into, here we are assuming x raised to 4 as x. So the derivative is 4x cube plus e raised to x raised to 5 into 5x raised to 4 into 5x raised to 4. Okay, so this is equal to e raised to x plus, here I'm going to put the value at value of x, that is we have 5 divided by dx at x equal to 1. Okay, so here I'm putting e raised to 1 plus e raised to 1 into 2 plus e raised to 1 into 3 plus e raised to 1. Here it is 1, right? So 1 power 4 is 1 power cube is 1, right? So e power 1 into 4 plus e power 1 into 5. So what is the answer here? It is actually e plus 2e plus 3e plus 4e plus 5e. So the total is 15e, right? It is 15e. So which option is right here? It is option B. Now, the greatest integer function defined by f of x is equal to greatest integer 0 less than x less than 3. 3 is not differentiable. So, we know graph of greatest integer function. Greatest integer means it is the greatest number, that is greatest integer that is less than or equal to the given value, which means if you are given 5.1, so the what is the greatest integer less than or equal to 5.1? It is nothing but 5. So the all the answer of this greatest integer function will be integers, right? It will be integer. So the graph is like this, right? The graph will be like this. So this is 1, this is 2, and this is 3. So they are talking about the domain 0 less than x less than 3. So in that domain, the graph of the function will be like this. Here they are asking that it is not differentiable at which all points in this interval. Within this interval, which all points we can say that the function is not differentiable. Here you can clearly observe that there is a sharp corner forming. There is a jump, right, at the points 1, 2, right? 1, 2. Here also you can see that 0, then 1, 2, and then 3. Here also there will be a jump. At point 3, it will go to 4, right? So here they are discussing about only the points in between 0 and 3. We are not talking about 0 and 3. So in between those 0 and 3, which all points the function is not differentiable, means here you can clearly see that at points 1 and 2, there is clearly a jump, right? A break or jump or a sharp corner. So we can say that at points 1 and 2, the function is not differentiable. So which is the answer here? It is option C. All right. Now, moving on to the next question. So y is equal to 5 cos x minus 3 sin x, then d square y by dx square plus y. So y equal to 5 cos x minus 3 sin x, right? So what is this dy by dx? Dy by dx is equal to 5 into cos x is minus sin x, right? So minus 5 sin x minus 3 into sin x. The derivative sin x is cos x. So this will become 3 cos x. This 3 cos x, and d square y by dx square is equal to minus 5 sin x derivative is cos x, and cos x is minus sin. So minus 3 sin x, right? So this is equal to minus 5 cos x plus 3 sin x plus 3 sin x. And what is this? D square y by dx square plus y is equal to minus 5 cos x plus 3 sin x. Then y is given as 5 cos x minus 3 sin x. So minus 5 cos x and plus 5 cos x gets cancelled. Similarly, 3 sin x and minus 3 sin x gets cancelled. So what is the value here? What is the value here? It is nothing but 0. It is nothing but 0. So which option is right here? Option A is right. Option A is right. Alright. Then moving on to our next question. If f of x is equal to x sin x when x not equal to 0 and k when x equal to 0, it is continuous at x equal to 0, then you have to find out the value of k. Okay, so they have given that the function is continuous at x equal to 0. You have to find out the value of k. If a function is continuous at some point, how can you write that? Limit x tends to 0. Since it is continuous at x equal to 0, limit x tends to 0, f of x will be equal to f of 0, right? Okay, so what is f of 0 here? F of 0, it is defined as k. So f of 0 is equal to k. F of 0 is nothing but k. And what is limit extends to 0 f of x? Limit extends to 0 f of x means it is even if it is less than 0 or greater than 0, it is x into sine x. Okay, x not equal to 0 is x into sine x. So this will become x into sine 1 by x. So we can split the limit, right? Limit extends to 0 x into limit extends to 0 sine 1 by x. What is limit extends to 0 x? It is nothing but 0. 0 into this one. What is the value of this one? It is sine 1 by x. If you are, it is not, if it is, if x is equal to 0, then we can say that it is not defined. It will become 1 by 0, so it will become infinity. So it is not defined. Here, or it is an infinite number. Here, it is x is approaching 0. X is never equal to 0. X is approaching 0 from the left and right side, right? So, which means x is never equal to 0, which means the sine 1 by x will always be a finite value. We know the range of sine is always minus 1 and 1, right? In between minus 1 and 1, which means this value will always be a real number, right? Or a finite quantity. This will be a real number or it will be a finite quantity. So 0 into a finite quantity. 0 into a finite quantity means it is 0 itself, right? It is 0. So here we have obtained that limit extends to 0 f of x is 0 and f of 0 is equal to k. And since it is continuous at x equal to 0, we can equate this, right? Which means k is equal to 0, right? F of 0 is equal to k implies k is equal to 0 because we have got limit extends to 0 f of x as equal to 0. Okay, so that is the answer. And the last question is, this, it is parametric differentiation. Here the parameter is theta. You have to find out dy by dx. So how will you do that? First you find out dy by d theta, right? Dy by d theta means d by d theta of a sine square theta. Since it is a constant, a is a constant, you take it outside. So d by d theta of sine square theta. What is the sine square theta? It can be written as sine theta the whole square, right? It can be written as a into d by d theta of sine theta the whole square, right? Which means the base function is some x square. It is of the form some x square. So it will be a into 2 sine theta whole raised to 2 minus 1, right? 2 minus 1 is 1. So a into 2 sine theta. But we can stop here. We have assumed sine theta as x, right? Which means you have to multiply the derivative of sine theta also. So this is equal to cos theta. Derivative of sine theta is cos theta. And what is dx by d theta? Again, this is equal to d by d theta of a cos square theta. Since a is a constant, you take it outside. So this will become d by d theta of cos square theta. So that is equal to a into cos square theta. We can write it as d by d theta of cos theta the whole square. Cos theta the whole square, right? So that is equal to a into 2. Okay, cos theta. What is the derivative of this cos theta? Into derivative of cos theta is minus sine theta, right? So this is equal to minus 2a cos theta sine theta. So we have found out dy by d theta and dx by d theta. Now what you have to do? You have to find out dy by dx. So dy by dx is nothing but dy by d theta divided by dx by d theta. What was dy by d theta? Which is equal to 2a sine theta cos theta, and dx by d theta is minus 2a cos theta sine theta. So this one get cancelled. What is remaining here? It is minus 1, right? So which is the answer? That is equal to dy by dx is nothing but minus 1. Okay, so these were some of the important questions that are asked in the 1 mark session. So in the next session, we'll be dealing with the 2 mark questions. So I hope this session was useful to you all. Thank you.